So I remember to create a title slide for this presentation, and basically we're going to develop a better polygon method here. I already have the method created, so I'm just going to walk you through it, and then we're going to write a program together, and I'm going to show you another idea here. So the polygon that we had was pretty nice. It would draw the turtle from the vertex. One problem with it though is it's pretty hard to calculate how big the polygon will be. So what we're going to do now is create a new version of Polygon called Polygon from Center, where we'll specify the radius of the polygon and the number of sides. And now in order to do this, what will happen is the turtle will move back and forth from the center, and we'll have to pick the pen up. It'll be a little bit more involved. So I've got some variables here that I've created. And I have to remember the x and the y coordinates of where I was, last x and last y, the next x and the y, the start x and the start y, and the center x and the center y. Looks like I didn't need to use start x and start y. Notice how NetBeans is telling me that I never used those. So let's just take a little experiment here and get rid of those. And so basically I'll have let's see here. Yeah, see, it doesn't look like those actually get used anywhere else. So I'm going to go ahead and comment them out here. And this might bite me in the ass, but we'll see what happens. Okay, so basically the idea here is I'm going to go to the center, go to the vertex, save the x and the y, then go to the next vertex, draw from the next vertex to the last vertex, return to the center, and go back to the next one. So I'll keep jumping to the center to calculate my vertex, and I'll remember the last vertex so I can draw. I also need a variable here for the angle and the heading, which is the direction the turtle is facing. So we'll have to keep turning the heading here to get the turtle to go to the vertex. The center x and the center y are the current positions of the turtle. So you can see as we come into the method, the first thing we do is we want to find out where the turtle is. So again, this method is going to draw a polygon centered on the current turtle position, and so that's what we get right off, and we're going to store that in center x and center y. Alright, we calculate the angle like we did before in the other polygon method. Now we pick the pen up, we move to the center. Actually, we're already at the center if you think about it, so that's not really needed. And then center y. And then we move forward the radius. So now we've moved out from the center to the first vertex point. Okay. Now we go down here and we're going to again pick the pen up. See, I forgot to mention that. So I pick the pen up and I'm already at the center, but I move to the center to make sure. Then from the center I move forward to the radius, using the radius as the length. So that's going to go to the first vertex. Okay, I hope you understand these terms like vertex. Those are the points on the polygon, right, where the segments meet. Okay, notice we have a loop that's going to draw once for each side that we have to draw. And again, we're at the vertex already. We pick the pen up, and then we go backwards radius, and that takes us back to the center, and then we turn an angle, and then we go forward radius, and that takes us to let's see. Oh, you know what? I did make a mistake here. I need these after all. I don't actually need the start x and start y, but I need the last x and the last y. Okay. Damn it. Alright, we'll put those back in. And that's what I get in trouble for here. Sorry about that. Okay, now we're good. So again, basically we went to the first vertex, and then we stored that value as the last x and the last y. It turns out that we aren't going to actually use the start x and the start y here. I just really need the last x and the last y there to be initialized. Okay, pick the pen up. We go backwards radius, which takes us back to the center because we didn't turn yet. Now we turn, and basically after turning, we're now pointed at the next vertex. Okay, so I went to the center, I turned the angle, I'm pointing to the next vertex. I move forward. That takes me to go to the next vertex. And then now I want to get the next x and the next y. So the reason I need that is I want to draw. So next x and next y are the current positions of the turtle. I've just recorded the next vertex coordinates. And then I'll grab the heading as well, okay, because I need to restore that. Then I'll put the pen down and I'll move to the last x coordinates, which actually draws the segment. So this draws the segment here. Draw a side of the polygon, okay? Then we're going to go back to the last point. We pick the pen up. Notice I have the next x and next y, so I move back to it. I set the heading back the way it was. And now last x and last y become the last one that I just did. And I loop and do the rest. Okay? So what this does now is it lets me draw polygons by specifying the radius, and it draws from the center point. So let's go ahead and write a program that generates a number of random polygons. But let's go ahead and try to figure out a way to center these on the screen within a border. So my screen is basically a picture that's 1024 by 1024. I know when I start the turtle, if I don't specify otherwise, it'll be in the center, which is going to be 512, 512, x and y. And now let's just suppose that we want to leave a border around the edge of the picture here. So if I wanted a border of, let's say, 50 pixels, then let me just make some notes here in the source code as comments. So if you think about it, if it's 1024 across, now the border will be 50 pixels in from the edge. So that would be 50 on the x, extending to 1024 minus 50, which is basically 975. I'm going to fudge a little bit here in the numbers. So that's going to be that on the horizontal, and because it's 1024 both ways, it's the same each way. Okay? So that means that going from the left, I don't want to start drawing before I get to 50, and I don't want to draw past 975 on the right. And then the same thing from the top and the bottom. So going from the top, I don't want to draw before I get to 50, and I don't want to draw past 975. Okay? So now just to see this, let's go ahead and draw a square with those coordinates on our background here. So I've already set the turtle, the picture up to have a yellow background, and then I've set the turtle to draw in black. And because we're drawing the border, let's make a real thick border here. So tom.set pen width, and we'll make that 4, which should be a pretty large border here. Let's go with 5. We'll make it really large. Okay? And then basically, I want to, let's see, is the pen is down. So let's pick the pen up. And here I'll make a comment here. So draw a square border on our picture. Now really I'm drawing the border so I can show it to you conceptually, so you can see how I can kind of use this math to calculate where things are on the picture, to position them more like I want. Okay? So basically, we're going to say Tom dot pen up, and then Tom dot move to, and this is going to be X, which is 50, and Y, which is 50. And you see how I got those? That's the calculations I did up here, where I know that my border is 50 wide. So it's 50 in from the up and down, and less than 50 from the edge. So that's going to move me to the upper left corner, and then I can just draw my square, Tom dot square, and whoops, why didn't it come up with the IntelliSense there? Oh, that's weird. I don't have square in here. Pardon. Okay, I forgot. I don't have square in here because I can use my old polygon function, which draws a polygon from the vertex. So polygon. Oops, how come that didn't come up with the IntelliSense? That always bothers me when it doesn't. Oh, here we go. Polygon from vertex is what I called that here in this library, because now I have two. Okay, so I want to do the length here. Now, how do we calculate the length? Well, it's 1024 minus 50 pixels on each side. So 2 times 50 is 100. So that's 924. We can say 925. 925. That's the length. And then since I want a square, I want 4 sides. Okay, let's go ahead and run our program here. Just all we should have now is our border, which should be, whoops, I forgot to put the pen down. Okay, so I move, and then Tom dot pen down. There we go. All right, here we go. Let's see, poly tester, that's correct. Alright, what happened here? Seems like we didn't get our complete picture. I wonder why that didn't draw. Well, that's kind of strange. Let me go back and okay, so I always like to leave the mistakes in here because that shows you my process and maybe helps you to work through them too. I forgot that when the turtle starts, it's pointing straight up. So when I moved it to set up the move here to draw the square, I forgot to change the way it was facing. So I moved it to the right position, but I also have to turn it here. So first thing we need to do is Tom dot right, which will turn it 90 degrees. Whoops, I think it's turn right here. Let's see, turn. Wow, I'm having a day of it here. Like I said, I think I need more beer here. Oh, it's right. Nope, nope, okay. T. There it is. Oh no, that's actually a constant. Damn it. Well, there we go. Alright, so let's do it again. You know what they say, fourth time is the charm. Okay, so now we have our border like I said. So again, what happened there was I moved the turtle to this position, and when I forgot to have it facing the right way. So when it drew the first line, it wrote like that. And again, when you draw off of the screen, things happen. So now we got our border here. And really, I wasn't going to draw the border. I just wanted to draw it here to conceptualize to you how I was going to try to fit things in. Okay, so now let's get on with our polygon program here. We want to draw a bunch of polygons, and we want them to be in the border. And we're going to use the other version of Polygon, which is the one that draws from the center. Okay? Alright, so I'm going to need a for loop here. And let's see, do we have any random here? Nope. So let's go ahead and add the random in. Let me put a little note here. Calculations for the border. 50 pixels on each side. Just so we know what that is there. Alright. So again, we've done this before. Random R&D equals new random Control Shift I to add the java.util random class. Whoops, didn't quite get it. Here we go. Control Shift I. There we go. I got it. Again, there it is. Okay. And then, alright, so I'm going to need the random to get random color. Let's come on down here and make our loop. Oh, and let me go ahead and add some space here to work in. Okay, so for int numgons equals 0, numgons is less than, I'm going to put a constant in here because I've been lazy about doing that. I should show you that. And then numgons plus plus, put in a body for our loop, pop up here to the top. Let's go ahead and put our constant in. So this is going to be final int numgons, and let's set this to 25 here. That's pretty arbitrary, but the idea is I'll go back in and change that if I want more or less. Okay, so I got a loop that's going to go 25 times, and it's going to basically draw a random polygon in a random position. So I have to generate the x and the y positions. And so the first thing I want to do is let's just go ahead and set them all to have the same radius. So I'm going to go ahead and create another constant for the figure radius. So final int figure, let's put a underscore in there to make this a little more readable. So figure radius equals, and so let's say 25 for that, which means that our diameter of our figures will be about 50. Okay, and that's actually about the same as our border. That's a bit small. Let's make this we'll go with 100 for our diameter, so we'll make this 50. Okay, so figures should have a diameter of 100. Okay, which means they'll be a little bit bigger. Alright, that sounds good. Alright, so I have my figure radius, and that's going to be fixed. And so now I want to get a center point. So we need to add some more variables in. Again, I like to put all the variables up here at the top. So int x center, I shouldn't do it that way. Let's do it this way. Center x, comma, center y. We don't need to initialize these here because they'll get initialized in the loop. And then let's see, and then I'm going to need a random color too, and I'll do that in the loop. Okay, all right, I think we're about ready to go. So let's go ahead and set our pen color. So tom.set pen color, and then this is going to be new color, and we'll randomize that like we do. New color, and rnd dot next int 256. Could use a constant there, but again, that's pretty standard number. I think we can probably get away with that. Alright, we paste that in, so we have one for each of our 3 color components. And it looks like we're good on our parens there. So we've now, let's add some comments here. Set random draw color. Oh, and by the way, we noticed before that it seems like it works better if we set the pen width. So right now the pen width is set to 5, which is really too thick for these. So let's set it back to 3. And so all of them will have the same pen width. And the same radius. Okay? Alright, so now we need to go ahead and calculate our random. You know what? And also we should put the pen up right away here. So tom dot pen up. And then we set the pen color. Now we calculate the x and y center. So center x equals random dot next int. Alright, now this is a little tricky, so look how this works. Basically, the width of my screen is 1024, but I've got a 50 pixel width border on either side. Actually, that's 55 because the 5 border is 5 pixels too, okay? So basically, if we say 100 from 1024, again, we rounded that before to 925 just for convenience. But basically what we want to do is we want to set that to something like 920, that's a little less, and add 55 to it. So this is going to give me a random number which runs from 920, 0 to 920, sorry. Plus the offset of 55, which is the side and the border. Okay. Now, because the y dimension is also 1024, we can just copy this and make this y center. Okay, so again, what I'm doing is I want to make sure that I get a center point that's not only within oh, I forgot, I have to add the radius too. So it's not only within the border, but also has to be wide enough for the radius. So we have to add the radius in here too. And what did we say the radius was? Did we use a constant for that? Figure radius. Sure did. Plus figure radius. Okay. So that means that basically I've calculated so that my random figures will not be drawn outside of the border that I want to have around my drawing. Okay? Now, we're ready to go. I have the center X and the center Y. It's going to randomize each time. So now I say tom.poly, whoops, poly, Polygon from center, and then numgons is not what I want. I want the number of sides, and that's going to be a random value here. And so again, I'll just throw a rand in right here. Again, I should probably well, no, because this is good. So random next int. And now let's think about this. So this has to be at least 3, so I start with a triangle. Let's basically make this a random value. What do we want here? Let's say up to 24 sides, and then a minimum of 3 sides. So 24 minus 3 is 21, and 21 plus 3. Okay, so that's the number of sides. And then this is going to be the radius, which is figure radius, which again, whoops, is a constant. Wow, having a problem here typing. Alright, and let's see, I put the pen up. Oh, I forgot, I have to move to the center before I draw. So, set the random draw color. You know, I'm doing this ass backwards. I should have typed all this pseudocode up to get my outline first. Move to the center. So that's Tom dot move to center X, center Y, and then we have to put the pen down right now, Tom dot, so we can draw. Okay, and then here we go ahead and draw. We could probably go ahead and put a comment in here like this. Draw the poly. Alright, sound good? I think we're good to go. Let's try it and see what we get here. So, drum roll please. Okay, looks like our calculations are off a little bit at the back end. So let's go ahead and adjust that. Also, I notice we're not getting any randomization here in the size. That means I had the parameters wrong. So let me go ahead and fix this. Alright, so basically the problem here is this number is too large, so I have to take the radius off the back end here. So let's go ahead and let's see, it seems like they were right on the edge, none of them were over. So I'm going to take figure radius here, which is what, 25? Figure radius is 50. Okay. See, this has become a magic number. Really, I should code this differently than I have. Because if I change figure radius, I won't remember to change this. But to just fix this on the fly, I'll go ahead. So minus 50 here is going to be 870. Alright. So now let's go down here and we're moving to the right position, but the problem here is I think I have these parameters wrong. So let's go ahead and if I get my display open in the IDE, I can, let's see, where is it? That's what I want right there. Okay, now let's click on turtle. And then if we go down here to poly from center, the radius is first. So you see what happened was I swapped these parameters around. So this just needs to be fixed. And come on over here. Grab the radius. Control C, Control X to take it out, get rid of the comma. Slip it back in here, Control V to copy, put the comma back in and a space for readability, save it. Okay, so let's go ahead and run this baby again. And now I think we should, here we go. Alright, so we still have some issues here where we don't quite have this offset correctly. And to be honest with you, I'm not sure why, so I need to think about this a little more carefully. But you can see that we're getting our values are all about the same. It looks like at this resolution, the 24 is really too much. It's not too interesting because we tend to get a lot of circles. So let's go ahead and manipulate that while we're at it here. Alright. Alright, let's just try a little bit different thing here to figure out our spacing. So I have a 50 width on each side plus 5 pixels, so we'll say 55 for the border drawn, and it's a total of 1024. So if we kind of do this as a sort of little diagram here, I've got an edge, then I've got 55 pixels, and then that means that I start here at 55, and then that extends to 1024 minus 55, which is going to be, well, again, if we just round it to 1025, that's 975. Okay, so 975, and then that's where my border is, and then I've got my 50 pixel width again. Oops, sorry, 55. Oh, right, 55. It should be 970. Yeah. One of the things I always tell my students is one of the best things I ever learned in school was the number line. In computer science, all the time you're looking at ranges, and so that's really what we have here is we have a range. Okay. Now the other thing is our figure radius is 50. So that means that I want this to be an additional 50 here, which means that I want the edge of the images to be basically from 105 to 920. So those are my center points. So I want 105 to 920. Okay. Now let's go ahead and real quickly just add a formula in here for this to show how we could do this on the fly. So basically this is 0 plus border width plus the line width of the border itself. Right, that gives me the edge, plus the figure radius. That's my low end, so that value equals the lowest, actually the the lowest possible center point. So lowest value for center point. All right, and then the highest value for center point is going to be 1024 minus the border width minus the line border minus the figure radius equals the highest value for center. Okay. Alright, let's go ahead and really fix this baby up and use the symbolic constants. So I'm going to go ahead and put these in now. So final int screen width equals 1024. Final int screen height equals 1024. And then we already have our figure radius. Let me just move that up. V, and then we'll delete it here where we had it down below, just because it's more readable. We'll put it up there. Okay, so now I can go ahead and just put a calculation in here. Let's see now, let me make sure I got it right. Oh, okay, we have to add the other things in there. So final int border and line. I'm going to say length here because this is the same in both dimensions, and width is a little confusing. So that's going to equal 50 plus 5 for the line is 55. Okay? Alright, so now I've got the start x already calculated correctly here, so let's come on down here. So center x, and then this 870 here, let's go ahead and get that. That's the number we need. So what that is that's the total variation from the lowest to the highest possible center point. And so the way that we calculate that is we subtract the low point from the high point. Okay? So again, final int high center equals you can use width or height here. The reason for that is that they're the same, right? I don't want to bother creating 2 extra sets of variables here, so I'm just going to be lazy. So I'll use screen width. So notice how I'm using the symbolics here. Screen width minus 2 times, let's see, so the high center is screen width minus 2 times the border and line length. I don't want to type that, so Control C, Control V. Let's see now, is that right? So I'm subtracting that. Yeah, that's the highest possible one. So high center here would be 1024 minus, 1024. Oh, damn it, there we go. 1024 minus the 2 borders, okay? And that's the highest possible number. And then the lowest is going to be final int low center. Whoops, let's make that all caps. Shit. Not 0 there. Low. Low center equals let's see now, that's the border and line length plus the radius. Oh, you know what? I forgot to take the radius off here. So it's minus 2 times the border length minus the figure radius. I probably should have made a diagram for you for this. I'm not sure this is going to make sense to you. We'll see. Alright, whoops, got a little typo in there. Okay, so final length low center equals, now that's basically just the sum of the stuff on the left, which is going to be the border and line length. Border. Oh, I think I still have that in the buffer. Sure do. Okay. Plus the radius. Figure radius. Okay, so now I have my low and high, and basically what I want to do is I want to subtract this from the high to get the number that I want. So the random value, final int, oops, rand center equals high center minus low center. And so then the way I'll do this is random center will get calculated. Let's see, high center is, oh, what's wrong with that? Why didn't it like that? Oops. Oh, I got a colon at the end rather than a semicolon there. There we go. Okay. So now what this is the number I randomize, and then I just add the border and line length there, 55, to it. Okay, let's come down and make this a little clearer here. So now center X is this rand center. And then, let's see, I think I already included the figure radius in that, didn't I? Yeah. So then I just have to add the border and line length. And since I'm going to do that twice, I'll go ahead and copy that, Control C. Pop on down here. Where is that? There. And then this is the same, so I'm just going to go ahead and blast it and recopy this. Now the reason they're the same again is because I have square coordinates here. Okay, so if I changed the dimensions so that it wasn't square, I'd have to have more calculations here. I'm just taking advantage of the fact that they're the same. Alright, let's give it one last try and see if it looks better. It looks like I still have a problem here now at the low end. So it looks like I didn't have the radius added to the low end there. So I have to add the figure radius to the low end. Let's see here. Low center, border plus figure radius. Border and line length. That's funny. I thought I added those in. So here, high center, we take the figure radius off. And there we add the figure radius in for the low. High minus low, that gives me the value plus. It looks like I have to add the radius in here too. I wonder if it's now going to be too long. We'll see. Plus figure radius. Why doesn't it like that? Oh, I misspelled it. Okay. Alright, now let's see. I wanted to change something here. So the number of polygons is right. The figure radius. Oh yeah, I wanted to change the how many sides it was going to generate. So let's see. So this is 21 plus 3. Let's take this down. And how about, let's see, 21 and 3. That goes to 24, which is really too much. Let's go to 18. So that would be 15 plus 3. Alright. Control save. Alright, let's see now. Oh, still got something running here. Got to close it. Alright, what do they say? The sixth time is the charm. There we go. That's looking good. Now, how about a little variation here in the side? So instead of, oh wait a minute, that'll make things too complicated. Alright, I'm not going to do that now. I would like to have more gons though, so let's come up here Let's make this 50 to get twice as many. I also think I'll go ahead and set the background to white. Alright. Well, again, you watch me flail through this mathematics. I probably should have gone ahead and used a diagram with PowerPoint or something for that, but we'll see. Alright, so it's looking pretty good now. We're getting our values. Not sure I like the white background anymore, but okay. Alright. So let's call this a done deal.